I'll be discussing is the working of HashMap in Java, how it works. So this is very important. So before I discuss about the complete internal working, first I would like to let you know like what is hashing, because
Hmm.
it uses hashing to store the key value data.
Hmm.
So hashing is nothing but it is a converting of an object into an integer value, because when we create any object, right,
Hmm.
it gives you a hash value which is a integer object,
Hmm. Hmm.
integer value,
Hmm.
and that integer value helps in indexing. Like with the that integer value we find out that the index,
Hmm.
and we go to that index, we save that data, and
Hmm.
similarly while fetching the data we find that index and we go to that index and get the data and return back. So
Hmm.
it makes our search faster also,
Hmm.
because we know
Hmm.
the index of the value, we directly go to that index and find the value based on the index. That we will be discussing here now in detail, how it works, what it does internally, how it looks,
Hmm.
kind of things. So everything in a hash map is a bucket kind of thing where we have a different set of value.
Hmm.
Let's say I told you like it all uses linked list also, right? So let's say we have a node, and that
Hmm.
node has a different value in it.
Hmm.
So let's say we have a node like this.
Hmm.
We have a node here, and we know like hash map how it works. Hash map, let's say for example if I take a hash map, in memory it will be like this, right, where we have a key and value.
Yes.
Let's say key is a, where I am storing city something. B, we have something, some string. C, some string. So our requirement when we have like key value pair, we go for hash map.
Hmm.
This is my requirement, but this internally how it works, externally this is the implementation. So we have
Correct.
key value requirement, we are going for hash map, and it in memory it do this. We have a key, we have a value, so we are saving it like this. Tomorrow I want to fetch data this, we'll just say map dot get, will pass a, it will find that a is available in the key or not. It says that a is available, so it will return the value city.
Hmm.
But how it does internally, how it works,
Okay.
so we will be discussing all this thing in detail now. So this you are saying, right, everything this one block.
Yes.
So this is
Hmm.
nothing but node. Let's
Okay.
consider this is one node, this is another node, or bucket kind of thing.
Okay. Key and value is one node.
So this is like normally, but when we have a collision, right, same index we got it, so we have a
Hmm.
collision also, so we will see how it handles internally.
Okay.
So everything we will see. So before we discuss in detail, I would like to know about this equal method and hashcode method.
Okay.
You know, right, equal methods are used to check that equality of the object,
Hmm.
and it compares based on the keys, because hash map works on these two methods.
Hmm.
So, and these two methods are part of the object class. Equal
Okay.
method and hashcode method are available in an object class, and object class is the parent class of all the classes.
Got it.
So you have to know these two methods, because hashmap internally uses the equal and hashcode method only to compare the value and get that hashcode to find that index. So
Hmm.
both the methods are used.
Okay.
So and one more thing. So one, if you override a equal method, right, then it is mandatory to override the hashcode method.
Okay.
This is very important. This thing it will take some time to understand in detail, but just think that If you are overriding a equal method, it is mandatory to override the hashcode method,
Okay.
or else the implementation will not give you the correct value sometimes.
Okay.
So
Okay.
it is a contract in Java.
Okay.
There is a contract between equal and hashcode method. If equal method is getting overridden,
Hmm.
it is mandatory to override the hashcode method so that consistency of the data is maintained,
Okay.
or else you will not have that consistent data.
Okay.
So this contract is there. Many people ask this also, like what is the contract between hashcode and equal method.
Okay.
So let's say there is a one node, and node has hash value, key value, and value, and then next pointer.
Hmm.
So I was telling, like, let's say this is a node, so it will have my index here, you saw, right? Hash value, then we'll
Hmm.
have key, then we will have value, and then we'll have next. These four things. Let's say I want to store, we have a map. Let's say hash map of string comma string, will take map equal to new hash map. We declare like this, right?
Yes.
And we are adding data here, map dot put. Inside we'll pass, let's say I'll pass some name, John is from Bangalore city, I'm passing something like this.
Hmm.
Okay, so when we call this map dot put method, what happens? How do we know, like, where in the memory it will be stored? Let's say this is my map
Hmm.
in the memory. How do
Hmm.
we know, like, where it will be saved? It will have some memory like 0 1 2 3 4, for example, index.
Yes.
So how do we know, like, which index this data will be saved internally?
Hmm.
So for this purpose, let's say this is my node. So each node will have hash value, because
Hmm.
then we'll have key value, which is nothing but this key we are defining. Then
Hmm.
we'll have value, which is nothing but this value we are passing. And then we have a pointer called next. This
Hmm.
next, why, I will discuss in detail where this will be used.
Okay.
So every node will have these four attributes
Okay.
inside it.
Got it.
Key and value you understood. We are passing it
Hmm.
from here.
Hmm.
Hash and next we will discuss now.
Hmm.
These two things are used in calculation.
Got it.
So now let's go back to slide. Now here you see. So let's say when we have a different node, we are calling it a bucket here.
Okay.
So
Array of nodes called bucket.
array of nodes.
Hmm.
So I discussed about the node, that is the smallest thing. Now we have a array of node. We are calling that as a bucket.
Okay.
So we have a 0 1 2 3, you are seeing in the list, right?
Hmm.
So how do we know, like, it will be stored at 0 index, it will be stored at 1 index, it will be stored at 2 index, it will be stored at 3 index, and so on?
Hmm.
Because I told you about the hash, right? So we calculate the hash of the key value object,
Hmm. Hmm.
and with that hash we find this index.
Okay.
And let's say I got that index is equal to 1, so it will
Hmm.
come to the first index and it will save there.
Okay. Okay.
Let's say next time I added key is equal to 34 and 51.
Okay.
With the hash I calculated that index and I got 2, so it came to the 2 index and added it here, and next
Okay.
is null.
Okay.
Similarly for 3, let's say again I added another object which is key is equal to 67 and value is 5. Index which I got with the hash is 1, but
Hmm.
when it came to the bucket and it checks that it is saying that one bucket
You're
at
already
one
full.
index already has the value.
Hmm.
So what it does, I had discussed you that it created a linked list,
Hmm.
and linked list has that capability to have that reference of the next node, right?
Hmm.
So this next pointer which you are seeing, that is nothing but it gives that reference of the next node. So you see here it is connecting with the next node.
67. Okay, got it.
So 67 is stored at index 1 only, but it is created a linked list, and it has
Hmm.
given the reference of the new node to the previous node.
Okay, so index is 1, but linked with the hash of the previous.
Yes.
Okay.
So let's say now I'll just make you more clear. So let's say here I have a that hash map. Okay,
Huh.
I'll just keep like this. Okay, we have this map here,
Hmm.
and we have this index. So let's say I added first object with the hash, I got index 1.
Hmm.
So I added it here. It will have three things:
Correct.
key, value, and next.
Hmm.
Similarly here also will have key, value, and next. Similarly here also key, value, and next. So let's say first when I did that calculation with the hash, I got index is equal to 1. So it will
Hmm.
go to index 1. It will, let's say key was my 10, value was 20, and null I will add null because we have nothing in the next.
Hmm.
Then again I added another object map dot put, let's say 2 comma 20 comma 40,
Hmm.
and with this I calculated that hash code. I got index 2, so it will come here, it will add 20, 40, null. Similarly I added another object,
Hmm.
let's say 60 comma 90, and I got index 3 here.
Hmm.
So it will come again here, it will add 60, 90, null.
Yeah.
Now let's say I'm adding another object.
Okay.
Let's say it keeps on, it's going like 4, 5, it's
Hmm.
and so on.
Hmm.
But now I added one more object, map dot put, let's say 100 comma 20, 120, and I calculated the hash, and I got index 2.
Okay.
But it went back here and it checked that it says that at 2 we already have a node
Node.
present.
Hmm.
So node, let's say node is here like this.
Hmm.
Here we have key, value, next, and this will also have some memory, right? Memory
Yep.
allocation will be there.
Hmm.
So here we'll add 10, 20, whatever is the value, and next will be again null. But
Hmm.
this node will have some value of the memory.
Yeah. Yeah.
So that we will link to this.
Got it.
So now this
That's
will
what
not
I
be
think.
the null. Here we'll have some memory value.
Got it.
So it will create a linked list inside, and it will reference to the memory of the this node with the previous node.
Got it. Understood.
So tomorrow let's say we have another object, again I got the index view. So what it will do, it will create a new
Add.
node, and here it was a null, right? So it
Yeah.
will map here
Got it.
like this, and it will continue.
Okay.
So every time whenever you create a map and you add the value to it, this operation happens inside it.
Backend. Hmm. Got it.
And this is how we calculate it. So
Oh, there's a calculation.
yes, this is one of the example. This function
Is
can
it?
be a different also,
Huh?
but
Is it It's custom.
yes, that's what I told you, right? By
Hmm.
default equal and hash code implementation is given by the Java, we use it.
Hmm.
But if you override the equal method, you have to override the hash code method also. So here you see we are having that, let's say in the example, right, we have we are adding anything to that map, and let's say I got some value. Hash code is nothing but it's a big integer value. If you print the hash code, let's say we have a hash code is nothing but it will be a big integer value like this. When you print, it will print you the big integer value. So we take that integer value, and here in this case we are using this and we are using this n is nothing but n is the size of the hash map or array. So with that we are calculating that index. So here you see, just for example we have given, let's say we have hash code is this 2657860 and 16 minus 1. If you do this operation you will get size 4. So at fourth index you can see that we have a node which has the hash value, which has the key value, which has the value of the map, and then we have the next. So it store the hash values, because if you don't store the hash value, how you will come to know when you try to get that value, when you try to retrieve the value with the same hash, it will find that index, right? If that hash is changed, you will get a different index and you will not get the correct value. So it stores internally everything, so that let's say it gets stored at index 4. So Aman is the key and 19 is the value which is stored at index 4. And now I want to get the value of Aman. So what you will do, map.get Aman. So it will find that hash code, whether the same hash code is present in the map or not. If it is not present, then there is no value called Aman, key called Aman.
Correct.
So if it is present, then it found that okay, there is a key called Aman, and with the same hash code it will calculate the index 4 and it will return you the value 19.
Got it. Understood.
So this happens internally inside when you create any hash map, and when you add that value you retrieve that value. So here is the same hash collision which I was talking about, you see.
Yes.
So at index 3 I got 2 nodes. So it has created a linked list and it has referenced with the memory of the next node. In the second example you have like two example, which is at index 1 and index 4. Index 4 we had a collision, so we created a linked list. In index 1 there is no collision, so there is only one node.
Got it.
So this is how like internally it works.
Got it.
And this is very important from the interview point of view, because people ask this question like how internally it works. So you should be very thorough, like what happens inside it, how hash code is calculated, how hash collision is managed when there is a collision, what internally happens when there is a hash collision. It creates a linked list and it adds the data into the map.
Yeah.
So this is how it works. Now we'll see that what is the advantage and disadvantages of the hash map. So since it works on the indexing, right, it is very fast, because if you know the index, basically it will access the data faster. And here you can store a null values, null as a keys.
Okay.
That is allowed in the hash map. You can have a null as a keys.
But multiple nulls if you have,
No,
then how will I know?
only one null is allowed.
Okay,
So that is there, and since it is non-synchronized, so it has higher performance, but it is not thread safe. Synchronized means it is thread safe, only one thread will be able to access at a time, but since it is not a synchronized, it will give you a better performance.
Multiple threads can access it.
Yes, at the same time multiple thread can access. Advantage is non-synchronized, which is not thread safe. Sometimes you need to have a thread safe, because in case of multi-threaded environment, that time you cannot use it HashMap. We have another HashMap which will be used, but not definitely HashMap. And it has a like key, value kind of thing. So it requires a more memory to store in the system, right?
Structure, yeah.
Yes, so because of the data structure, it requires significant amount of memory. That is like internal structure is like that. So it consumes more memories. So that is another disadvantage. And it does not maintain any order of the data how you insert into that map.
When you print it, it's
Yes,
random.
it's a random.
Hmm.
So these are the few disadvantages and advantages. So this was the second topic which I wanted to discuss today.
Hmm.
And in this you are able to understand everything, right? Or do you have any queries which you want to ask as of now, like how it works? Did you get it completely?
Yes, this I understood. I think one which I didn't understand is the override. I think it is using that annotation, no, like override.
Where?
You said key and equals, and this thing has to be overridden.
Overridden, it means like these equals and hash code are the built-in method.
Huh. Okay.
So overridden means, what I wanted to say is that, let's say,
Yeah. Is it using that
so
annotation you
no,
mentioned
it's
and?
not annotation.
Mm-hmm.
um, Basically what do you mean by override is, let's say there is a object class
Hmm.
which has this equal method
Hmm.
and override method.
Okay.
Okay, and we use this method, already implementation is given, we are not changing the implementation of equal method and override method.
Hmm.
So any class we create, let's say I created a class student.
Hmm.
So since this object class is the parent class of all the class,
Hmm.
already this class will have this method, right? Equal and override method.
Yes.
And implementation is given. So if you don't give custom implementation, whatever is the implementation provided in the object class, it will work as expected. So let's say equal method, I want to write my own logic here
Ah.
in the equal method. Already equal method implementation is given, but
Hmm.
I have a requirement which is not suitable with the built-in method. So
Mm-hmm.
you will
Got it.
override this method.
Okay, so this is possible. Like, I just wanted to know. For example, you have like um, dot add method. Okay, so and the implementation is given that a plus b.
Yes.
But you can override it, saying that add can be a minus b.
Yes, you
Is it
can overwrite. You can always overwrite a built-in method, but you need to
that?
implement that overridden logic. You have to do it.
Okay, and
So
that has to be created as in custom implementation and
yes,
class.
yes, whatever is the built-in method you can do. So that's what I was trying to make you understand. So this method is implementation is already given. So
Hmm.
there is a contract. If you override this, override is
Hmm.
nothing but if you change the implementation of this method, you
Hmm.
will have to change the method of override method also, because
Okay.
this override implementation is done based on this method. So
Okay,
if
okay.
you
The
make a change over
changes.
here, you have to make a change here as well.
Okay, okay. Got it. Understood.
So that is all for today.